We are going to learn about the second order Runge method. Let us take an equation first. The equation is taken the dy by dx is equal to x square plus y. Dy by dx is equal to x square plus y with the initial condition that y of 0 is equal to 1. Now, if we take a graph x and y axis over here from 0 to x, let us say 1 and 2, y axis 0 to y, in the y axis 1 and 2, and we divide from 0 to 1 just to zoom it up at h is equal to 0.02. H is here the step size. Step size is taken as 0.01. We can decrease the step size also. More we decrease the step size, we will get better accuracy. So the initial position is known. Slope at every point of x and y is known. Dy by dx is known. Now, if I know the dy dx, I can find what is the slope at the 1 and 1. Also, I can get the slope at 2 and 1, that is 70 degree. Here also 40 some degrees, 45, and here also 45 degree. Now, what if the equation is at the initial position is, let us say, x0 and y0, what will be the x1 and y1? For any value of x1, what will be the y1? That is the objective. So, in the first order Runge method, second order Runge method, sorry, we are finding by taking the two values k1 and k2. Then we do the average of that, k1 plus k2 divided by 2. We get what is the value of k, and that k is added with the initial value of y, that is y0. So let us say first we are at x0 and y0, correct? Now x0 and y0, we put on a slope to get the slope of that f of x0, y0. That slope, when multiplied with the x, you remember the y is equal to mx plus c, where m is the slope, x is the x-axis distance, plus c is the y intersection point. Assuming the c is y intersection point is 0, remove it. We are taking y is equal to mx. That m is nothing but f of x and y, that is the slope. That small distance in the x-axis is h. So h multiplied with f of x0, y0 will give you the, for the small distance in x, what is the small height it has reached, that is k1. So k1 is obtained is equal, k1 is equal to h times of f of x0, y0. We get a small height k1. Now, once we get k1, what is the new position? The new position coordinate will be, in the x-axis it is h, in the y-axis it is y0 plus k1. At the new position, we can again get a slope. That slope multiplied with h will give us another height, that is called k2. If we see here over here, the small h, what is the height we get is k1. At the new position, again with a small x-axis distance of h, we get a new position of k2. So this particular example where we are taken f of xy is equal to x square plus y, we get our initial position, the slope is 45 degree. At a new position, the slope is a little bit of higher, of say 45.57 degree. So this is just for a layman language to understand. Initially it is 45 degree, then we get a little bit of higher, 45.57 degrees. Now the average of that will be near 45.23. This will be nearly the average. So what is the new value of y1? Y1 is equal to, obviously, x-axis distance, that is 0.01, into the average of the slope, that y is equal to mx. We can find in that logic, or we can say we get a k1 and we get a k2. So what we can do, k1 plus k2 divided by 2, we get an average value of the k height, multiply added with the initial value of the y, we get a next value of y1. Now in the second iteration, what we can say y1 is now equal to y0. Again we find the k1 and k2, get a value of y2. Like that we will proceed, and with a small step change in the iteration method, we can go up to from y0 we get y1. Again in the second iteration, from y1 we will get y2, from y2 we will get y3. Like that will go, and up to, if we divide that into n number of iterations to reach from 0 to any point 5, and we divide into 50 number of iterations, so 50 number of iteration we can reach up to x is equal to 5. What is the value of y? If on all over a state we take a single value of x, we get a single value of y, we are getting just adjoining the 2 points. One is at x0 y0, another is x equals to 5 and y whatever the value we get here there. We will not be able to know what is the value of y at x equals to 5. So with the help of going through the slope one by one, we are able to know what is the value of y at x equals to 5, and we get at that point. And in that way we can get the waveform. And that waveform is what can be obtained through this method, is called the Runge kutta method. And this is not only the second order, we can go for third order, fourth order. Depending on the number of variables, the order may change. Suppose we have 4 different variables are there, we will go for fourth order Runge kutta method. In that way we will get new value of k. K is equal to, suppose third order, k is equal to k1 plus 2k2 plus k3 divided by 4. Or we can take is like k is equal, fourth order Runge kutta method, k1 plus 2k2 plus 2k3 plus k4 divided by 6. So fourth order Runge kutta method we can do like that. In this way we can find for different value of x what is a different value of y, and we can plot the curve. Thank you very much.